Hello everyone, welcome back to my channel Cat Voyager. This is me Mayanka Chattopadhyay and today I am back with another problem. This is day 13 of our series of daily QA problems and the problem on your screen is again a PYQ from Cat 23 Slot 2 paper. This is a problem on quadratic equations. So let's get started. They have given a particular equation which is your x minus 1 whole square plus 2kx plus 11 equal to 0, and they have said that let k be the largest integer such that this particular equation does not have any real roots. Okay, then they have said if y is a positive real number, so y is a positive real number, that means y is greater than 0, and they have finally asked us to find the minimum possible value of k by 4y plus 9y. We have to find the minimum value of this. Okay, fine. So this is a quadratic equation and we have to take it in the form of some ax square plus bx plus c, that is the standard form of a quadratic equation. This is equal to 0. So we will break this thing open. It will be x square minus 2x plus 1. Then we have plus 2kx plus 11 equal to 0. Or we have x square. Then the coefficient of x will be bundled up from here and here, and it will be minus x goes common. This is 2 and this is your minus 2k. Okay, and the rest of the constant term is nothing but 11 plus 1, that is your 12. Fine, we have it in this particular form. Now they have said that this doesn't have any real roots. So in our previous videos we have seen that there is a thing called discriminant which is denoted by b square minus 4ac for a quadratic equation. This b, a and c are taken from this a, b and c, right? And if this discriminant denoted by d is less than 0, then we have no real roots for that particular quadratic equation. Okay, so let's evaluate this discriminant from here. What is your a? Your a is the coefficient of x square, which is 1 here. Your b is nothing but the coefficient of x, which is minus 2 minus 2k, or you can say this is 2k minus 2, right? And your c is your constant term, which is 12. Fine. So now we will evaluate this b square minus 4ac. That will be your 2k minus 2 whole square minus 4 into 12 into 1. Okay, when we break this open, this will be your 4k square plus 4 minus 2 into 2k into 2, that will be your 8k, minus this 4 and 12 is 48. So we will have 4k square minus 8k minus 44, that is your b square minus 4ac or your discriminant. Now we will write this in the inequation form. Your discriminant is less than 0, so 4k square minus 8k minus 44 is your less than 0. We will divide both the sides by 4, so we will have k square minus 2k minus 11 is less than 0. Okay, now we will understand something from here. Let we have an inequation in the form of this x minus a into x minus b less than 0. How do we evaluate the domain of this particular inequation, or the range of the values of x for which this inequation holds true? We draw the number line. This is your minus infinity to plus infinity. we put some a and b, and we try to check the validity of the inequation within this intervals, right? So let's take something less than a, or your x is less than a. Then this x minus a becomes negative, and this x minus b becomes definitely negative. Multiplication of these two negatives will give you positive, so you will have something positive here. Within a comma b, we have the value of x greater than a, so this will give you positive, but the value of the x is less than b, so this will give you negative, and positive into negative is your negative. Fine. When we have in this interval the value of x is greater than b and obviously greater than a, so this two, x minus a and x minus b, both will be positive and the multiplication will be positive. So the only range where the inequation satisfies is within a and b, and we say that x belongs to this a comma b interval, right? Same thing will happen here. This is a quadratic polynomial, and when we break this and write it in some form, say k minus a into k minus b, this a and b can be any number, this will be less than 0, and from here we will say that k belongs to this a comma b range, right? So to do this, we have to find the roots of k, or the values of k. So that will be, from our formula we know that k will be our minus b plus minus root b square minus 4ac by 2a. Your b is minus 2, your a is 1 here, and your c is minus 11. Okay, fine. Then the values of k will be 2 plus minus root minus 2 whole square is 4, minus 4 into 1 into minus 11, so this thing will become what, plus 44. Okay, and this is your divided by 2, so your k will be 2 plus minus root 48. Why? Because this is 44 and this is 4, so 48 by 2. Now 48 is nothing but your 16 into 3, and root 16 will give you 4, so this thing will be 2 plus minus 4 root 3 by 2, or k will be 1 plus minus 2 root 3. That means your k will lie between these two roots, or 1 plus 2 root 3 and 1 minus 2 root 3. So they have asked us to find the largest value of k such that this thing happened. What happened? That this particular equation didn't have any real roots. So we are concerned with largest possible integer value of k. So we will have to evaluate this thing. This is nothing but your root 3 is 1.732, that multiplied by 2 will give you, this is 4, 6, and this is 3.464, and we have a plus 1 here, so it will be what, 4.464. So we have k is less than some 4.464. That means the largest possible integer value of k is nothing but your 4. Okay. Now the expression for which we have to find the minimum value is this one, k by 4y plus 9y. Okay, fine. So we will write this. The expression is k by 4y plus 9y. The value of k we are using is 4, so this will be 1 by y plus 9y. We have to find the least value of this particular expression. Now there is something which is known as AM-GM inequality. AM-GM inequality. So first we have to understand what is AM and what is GM. AM is nothing but your arithmetic mean, and GM is your geometric mean. Suppose we have n numbers denoted by A1, A2, A3, dot 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 an, total n numbers. Okay, all these numbers are real numbers which are non-negative. Okay, that means ai is greater than equal to 0 for all values of I in the range of 1 to n. Okay, so the arithmetic mean of all these numbers is given by a1. This is your arithmetic mean given by a1 plus a2 plus a3 plus dot 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 plus an divided by the number of total numbers, and your geometric mean is given by a1 a2 a3 dot 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 an in multiplication form, the nth root of this multiplication, or a1 into a2 into a3 into dot 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 into an power 1 by n. And the AM-GM inequality states that AM is greater than equal to GM, and this equality only holds when your a1 is equal to a2 is equal to a3 and all the numbers equal to an. Okay, you can take one example. Suppose you have 5 numbers which are all ones, right? All ones. The arithmetic mean of this particular thing will be what? 1 plus 1 plus 1, 5 ones divided by 5, that will give you what? Nothing but 1. Okay, and when you take the GM, that is your nothing but 1 into 1 into 1 power 1 by 5, or 1 power 1 by 5, which will also be 1. So you have your AM and GM equal because all the numbers are equal. Okay, so we are concerned with this AM-GM inequality. How? We will see. What was the final expression we had? We had 1 by y plus 9 by y. Sorry, 1 by y plus 9y. So we have what? 1 by y plus 9y. Now let's take this term as some a, this is some b, and we will apply the AM-GM inequality. So AM-GM inequality states that a plus b by 2, because two terms are here, is greater than or equal to your square root of a into b. Why square root? Because only two terms. Okay, so it will be your 1 by y plus 9y divided by 2 is greater than or equal to a is 1 by y and your b is 9y. This will be 1 by y plus 9y by 2 greater than equal to root 9, or 1 by y plus 9 by y greater than equal to 2 into root 9 is 3. So this is nothing but 6. That means your 1 by y plus 9y is greater than equal to 6. Why we are not taking the minus 3 value? Because we have already mentioned that these numbers have to be greater than or equal to 0, and they have already mentioned that in the question that where it is your y is a positive real number. They have already mentioned that, so we are good to apply the AM-GM inequality actually. Okay, so we have the final value of the expression. This expression has to be greater than or equal to 6. That means the minimum value of this expression is 6, and that is your answer to this particular question. So that's it for today. If you like this video, if you enjoyed this video, please don't forget to like, share and subscribe. Please share this video among your friends so that they also can learn something from it. At the very end of this video, I have attached a playlist where I have included all the previous videos I have made so far. If you haven't already, I would definitely recommend to watch those videos. They contain good problems and they will surely reinforce some of your basic concepts, or you may learn something new from them. If you want me to make videos on any particular topic, please mention in the comment section, or you can personally reach out to me. Thank you for watching, and I will be back tomorrow with another such video. Until then, stay tuned. Bye bye.